Hello everyone. I'd like to take a bit of time today and talk about inverses of a function, chapter 6, section 6 of our text. Now if you'll notice up here in the title, 6.6, inverse of a function, calculator. What that means, folks, you may use a calculator for as much of this as you want to. It'll be especially helpful when we talk about the graphs. So, the first part of this, we want to solve for x, and then find the input when the output is minus 3. Now, inputs and outputs, we've talked about these before, but in case it's been a while, our inputs are x values, and our outputs are the y values. So we want to solve for x, then find the x value that makes the y value negative 3. So let's go ahead and do this. We have f of x is equal to negative 2/3 x plus 1. We want to solve for x, so we want to get x by itself. So let's rewrite this. So as we should remember, f of x is another way of saying y. Y is equal to negative 2/3 x plus 1. To isolate that x, we're going to subtract 1 from both sides to give us y minus 1 is equal to negative 2/3 x. And then we're going to use our reciprocals. Now we've been using reciprocals before, but in case you've forgotten, the reciprocal is basically the flipped version of whatever is in front of that x. So in front of the x normally was negative 2/3. The reciprocal of that would be negative 3/2. So to get rid of that negative 2/3, what I'm going to do is I'm going to multiply both sides of this equation by a negative 3/2. Remember in our parentheses, okay. Now, on the right side of our equation, we should see that this negative 3 and that negative 3 will cancel out. This 2 and that 2 will cancel out, leaving the right side of our equation as simply x. Meanwhile, on the left side of the equation, our negative 3/2 is going to distribute onto that y and onto that minus 1 to give us negative 3/2y plus, because a negative times negative is a positive, plus 3/2 is equal to x. We have isolated x. We have solved for x. The next part, we want to find the input when the output is negative 3. So what is x when y is equal to negative 3? Let's go ahead and plug in those values to solve this problem. We have negative 3/2 times negative 3 plus 3/2 is equal to x. Well, negative 3 times negative 3 gives us a positive 9. So this becomes 9/2 plus 3/2 is equal to x. 9 plus 3, well, that's going to be 12. So 12/2 equal to x, which is the same as 6. When x is 6, y is going to be negative 3. This is the first step really of finding our inverses. In these next few problems, we're going to find the inverses and work with them in different ways. Now the first step for finding the inverse, we always want to switch our x value and our y value. Remember, our f of x's, our g of x's, our L of x's, our d of x's, all of those function form notations are stand-ins for our y value. So we look here at number 2, find the inverse of the function, then graph each function and its inverse. So we have initially f of x is equal to negative 3x. Our first step, swap our x and our y. So we have x is equal to negative 3y. Now, isolate the y. To get rid of that negative 3, we divide both sides by negative 3. Those cancel out there. We get x over negative 3 is equal to y. Unfortunately, this program's not letting me graph these lines cleanly, so I'll make a separate video with 2, 3, and 4 fully graphed out. For now, let's move on to number 3, sticking to solving for our inverses. Our first step, swap our x and our y. So our f of x is equal to x minus 3 cubed. We know that should be y is equal to x minus 3 cubed. We're going to swap our x and our y. X is equal to y minus 3 cubed. We get rid of that cubed value by taking the cubed root of both sides. So we have the cubed root of x is equal to y minus 3. We move that minus 3 over to give us the cubed root of x plus 3 is equal to y. In number 4, things are slightly different because now we have this added x must be less than or equal to 0. This means we're only going to graph, when we get to the graphing, we're only going to care about the values of x that are less than or equal to 0. You'll see a little bit later on where this takes place. But for now, let's work out the inverse. F of x is equal to 9x squared. Y is equal to 9x squared. Swap our x and our y. X is equal to 9y squared. Divide both sides by 9. X over 9 is equal to y squared. We get rid of that squared value by taking the square root of both sides. We take the square root of a fraction. If you may recall, this allows us to take the square root of the numerator, square root of x, and the square root of the denominator, square root of 9. Now before I write the rest of the y part of this equation, square root of x we don't know. So that's going to become, or rather say as, the square root of x. But the square of 9 is 3. Specifically, plus or minus 3. And all of that is equal to y. Now, we go back to our y must be less than or equal to 0. Values that are less than or equal to 0 cannot be positive. As such, we don't actually care about the positive side of things. We only care about, let me clean that up a little bit, we only care about the negative values of this equation, of this function. So our final answer becomes negative square root of x over 3 is equal to y. In numbers 5 and 6, we want to determine whether the inverse of f is a function, and then, whether or not it is or isn't a function, find the inverse. So, we've talked previously about the vertical line test, the test that we use to determine whether or not a function is truly a function. The vertical line test says that if we have some function, some graph, where we can draw a vertical line and it passes through one or more points, that it is not a function. The horizontal line test deals with our inverses. That is to say that if we have a function and we have a horizontal line going through it that touches multiple points, then the inverse does not exist as a function. The inverse does exist, but the inverse is not a function. You might also remember from when we were talking about polynomials that the highest power of the polynomial and the leading coefficient of that polynomial determines the shape of the graph. Looking here at number 5, our highest power is x to the third. Our leading coefficient is a negative. If you recall, we have negative x to the third power. Our general shape of this is going to be our disco dancer. There is no location here where a horizontal line would hit multiple points. As such, this passes the horizontal line test, so the inverse of this function, the inverse of number 5, would be a proper function. Now, let's solve for that function. So our first step, we have our equation of y is equal to negative x cubed plus 3. First order of business, we're going to switch our x and our y. So x is equal to negative y cubed plus 3. We then take that 3, move to the other side. X minus 3 is equal to negative y cubed. Next, we have to get rid of that minus sign. So we're going to multiply everything by a minus 1. Minus x plus 3 is equal to y to the third power. How do we get rid of that third power? Well, we divide everything. Let's see, what color have I not used yet? Not divide everything. We take the cube root of everything. So that gives us as our final answer the cube root of negative x plus 3 is equal to y. That is our inverse. In number 6, our highest power is even. Our even powers mean that we have a U-shaped graph. So even though this is going to be slightly shifted because of that minus 6 inside the parentheses, the general shape of this graph is going to be a parabola. Now this parabola has multiple points where it fails the horizontal line test. So the inverse of number 6 is not actually a function. However, we still need to find it. So, set it up. Y is equal to x minus 6 squared. We're going to take the square root of both. We're going to swap x and y. So x is equal to y minus 6 squared. We're going to take the square root of both sides, square root x, is equal to y minus 6. Then we'll move that minus 6 over. So we'll have the square root of x plus 6 is equal to y. Because we're doing the square roots, we have our plus or minus. But this, folks, is not a function, because we'll have a area where on the inverse it will fail the line test. Moving right along, numbers 7 and 8, we want to determine whether the functions are inverses. There are two ways we can do this. Number 7 is an excellent way of showing the algebraic way of identifying inverses, whereas number 8 is an excellent way of the pre-cal calculus version of function notation, using some of the function operations that we talked about in 6.5. So we'll go to number 7 first. We have the two functions. We have our x minus 3 over 4, and we have our 4x plus 3. We want to determine whether or not these are inverses of each other. The algebraic method of doing this, we pick one. We solve for the inverse. If the inverse of what we found is equal to the other equation, then the two functions are inverses of each other. Now, between a fraction to start off with and a non-fraction to start off with, I'm going to pick the non-fraction to start off with. So I'm going to solve for the inverse of g of x. Y is equal to 4x plus 3. Swap our x and our y. X is equal to 4y plus 3. Move that 3 over. X minus 3 is equal to 4y. Divide both sides by 4 to give us x minus 3 over 4 is equal to y. If we go back and we look at our f of x is x minus 3 over 4 equals y. Here we have x minus 3 over 4 is equal to y. Because the final form of g of x, the final inverse of g of x, is the same as the starting equation of f of x, these two are inverses of each other. Number 8 involves the functional notation form. The way we do this is we're basically going to write either f of g of x or g of f of x. What this method does is basically pick one of these two equations, either a g of x or f of x. We plug in whatever is on the right side into the x value of the other equation. It works the same way as if you had an f of x and f of 5. You would plug in 5 for all the x values. I'm going to go with g of f of x. So what I'm going to do is I'm going to take my f of x equation, 7x to 3 over 2 minus 4, and now I'm going to fill in my g of x equation. So what we're saying here is that this entire f of x is the same as that x right there. So if we treat this like the numerator of our g of x, we need a plus 4. We need a divide by 7. We need that exponent out there, 3 over 2. And now we solve it. And our goal, if this is an inverse, we should get x by itself as our final answer. If we get anything that's not x by itself at the end, this is not an inverse. So, first things first, we have a minus 4 and a plus 4. These two are going to cancel out. We also have a 7 and a 7. Those two are going to cancel out. And that will leave us with x to the 3 over 2 raised to the 3 over 2. Now, you may recall, if we have an exponent being raised to another exponent, we multiply the two exponents together. So x to the 3 over 2 to the 3 over 2 is the same as x to the 9 over 4. X to the 9 over 4 does not equal x. So here in number 8, these two are not inverses. And that, folks, are our notes. If you have any questions, please don't hesitate to email me. I'll be more than happy to answer your questions. If you'd like me to do video chats with you, video help, video tutoring, please make sure your parents email me so we can sort that out. Have a good day.